Let's start the story from the beginning, so if it will be repeated, it's also fine. So we will try to explain what we are doing, but start to explain what is reality now and how we can improve this process. So usually we have Alice and Bob, both of them entrepreneurs, right? So they are doing some business together. What does it mean for us? It's basically they're managing their ledgers, right? So they're doing their bookkeeping, they're managing their inventory, each of them, in their own system, and it's fine, right? So, but what can happen? So instead of Alice, we might have a Bob. Instead of Alice, we might have a hacker, and then Bob is screwed. And we can have situation in opposite ways. So Alice might deal with hacker, and then Alice is screwed. But yeah, you all right? What shall we do? Is both of them are hackers. The whole system is screwed. But another case that Alice and Bob, they're good entrepreneurs, they're doing their business together. Someone as intermediary, man in the middle, interfere in between, and for example, when Alice sent invoice to Bob, he or she or they can manipulate with that invoice and just change a number. Yeah, so if you think about bank account, so Alice sent invoice to Bob, hacker change a bank account, so Bob will pay to that bank account and money will go somewhere else. The same it can be done, with manipulation on the data which they store with their ledgers. And it's a big problem for everyone. It's exactly, we invest in a lot in protecting data, in data replication, in anti-hackers attacks, in everything else, just to keep the data consistent and unmodified. What other use cases? It's, for example, tax authority. Tax authority, they would like to see some information about business of Alice. They will see lots of information, what we call privacy issue, right? So tax authority, they would like only to see how much taxes you need to pay. Instead, they will see all your information with whom Alice is doing business. How much they're buying, for how much she is selling, etc., etc. And the next case, that, for example, to prevent VAT carousels and things like that. So, tax authority, they will check not only ledger of Alice, but they will check ledger of Bob, and it's not a good situation. So it's called like cross-checking, right? So they will extract one ledger, extract another ledger, and say, okay, this invoice for 100 euros should be here as well, and vice versa. This is done in order just to verify that invoice is correct and no one manipulate with the data. If we looking at real life, so it's not about invoices, so we have orders, then we have goods which is delivered, we have invoices, and money flow which is going also in a separate flow. All of this is kind of complicated way, complicated workflow and complicated, scenarios how people doing business together. Next. And as Johannes already mentioned, probably Bob is, sometimes he need to manage his cash flow, so he will go to a bank and say, okay, can you give me some money? And bank, they are not usually, they would give you money, but they would like to see all information about invoices, about inventory, about everything, all your history. Why? Because they also know about hackers, they also know about man in between, they know about all this manipulation with VAT and everything else. So they simply don't trust everyone. They don't trust in invoice, they don't trust in any information. So it's a digital information, can be manipulated, can be tempered, can be removed, etc., etc. So what does it mean? People will pay for it, like Bob, with low loan coverage. That, for example, Bob want to take loan from a bank, so he would say, I have in my warehouse some goods for $1 million, and bank will pay, 50% coverage of that. So he might get only 100,000 from a loan from bank because it's high risk for banks, right? They don't trust to anyone because they simply don't trust the data. Yeah. So why is that? No trust from bank, high risk, and high operational cost. High operational, so no trust, high risk is kind of simple. High operational cost is meaning that bank, they in many cases they will just send some of their employee to check either your ledger or to check inventory on warehouse. A lot of manual work, a lot of really, like experts. You need to have certificates, etc., etc. So data by itself, digital data, is not a truth data. What we can do differently? So what if we have, a source of truth? Let's imagine the source of truth. So source of truth, it will be kind of digital storage. Whenever we put there, it will be there forever, and no one can manipulate with that data. Sounds cool, right? Then you don't need to worry about backups, hackers, etc., right? So, let's look at the property widget, about property of that system. One of the properties is immutability. So immutability is a property of a system, so you cannot change anything, yeah? So if you write something like written in stone, if you write something, you can only destroy it. Second one, if you have, let's say, immutability, but you want to modify data, so what you do, you create another record on top of it. So it's called append only. Immutability and append only give you really good traceability. So you can trace all the changes what happened to a digital entity. Next one is no central point of failure, availability, and distribution. So it's all coming together. So data is distributed, there is no point of failure, and since it's also distributed, so it can easily be accessible from any places. Transparency. So the whole data should be transparent, really visible what is going on. Together with traceability, transparency gives to this system really good advantage, and a lot of use cases which can be done on top of it. So if you look at all of these properties, so it's simply blockchain. Sounds familiar, right? So what we can do, so we will show one of use case in which we will show how does it work, what it can bring in this case. So Sergey started Exact Online. Exact Online is a product of Exact. So usually what people doing with this product, so they just creating invoices, so they are managing the ledger of invoices. They can create inventory, and based on that, we can create financial information. And so Sergey just simply will do invoice. So he create emulate a process that Alice is doing some consultancy for Bob. Invoice is created. Just put some amount. Save. By the way, who never saw, this is how Exact Online is look like. Okay, nothing really changed for entrepreneur. So for those who are more familiar with Exact Online, so this is a process how people doing, day by day, and why we are talking about blockchain. Let's go. How does it work? I will explain a story. So we have three layers. What we are saying, so we propose to have, let's say, 3 layers. One layer is application layer. An application, this is ERP system, banks. So those applications which So underneath we have another layer, which is data layer. Data layer this is a layer where all those applications save their data. Usually we call them database, right? So bank will manage your bank account in their database. We as Exact, we use our own database and manage the data. If we add another layer, blockchain layer underneath, and use that layer only for pointers. Yeah, I will explain later on what does it mean, but if you look at this schema, so traditional model, we have 3 different applications. 3 different applications will manage their own data with a timestamp, you know what is going on. If we take a small piece of each application with a timestamp, and put it on blockchain, so we will have additional layer of communication between different applications. You write some data, then from another application you can read it and can always verify authenticity of the data and with a timestamp to see traceability of it. How does it work? So at the moment when Sergey creates invoice, it's step number 1. So we create the data records in our private database, which is managed by Exact, with all the security, compliance in place, data recovery and all these procedures. So we are quite good at that, so doing lots of years already. And second, point number 2, so at the same time we also create a hash. Hash was already mentioned a few times today. So hash is a fingerprint of a digital asset. So for example, if you think about like a file, even movie, so you can do a hash, this mathematical function. It will produce a long string of strange characters. The beauty of this is if you change in this big file, like a video stream, even 1 bit, so that hash outcome will be totally different. So you can easily say that that file was not original anymore. Someone manipulated with the data. Someone changed 1 single bit. So if you think about invoices and any other digital asset, it can be represented as a file at the end. Then you can do a hash function out of it, and with a hash function you can put that hash output those characters on a blockchain. So in the future, in any point of time, you can get your invoice, make the hash out of it, and compare it with that one which is safe on a blockchain. So if they are equal, good, no one modifies the data. Next to hash, we also add URL to original data to our API. So by calling that, you can get original invoice. So we are not saving the whole invoice on a blockchain because it will be publicly accessible, everyone can read it, and our customer will not be that happy about it. And a hash, it's only one-way function, so you cannot recreate invoice out of hash, right? Okay, it's step number 3. Bank can see this information, or any other third-party company. They can read this information, and step number 4, they can request original information. So bank will see, okay, new hash for this invoice is coming. I want to see what is there, right? And then customer in Exact Online can say, okay, I want to give access to this bank or not, yes or no, or bank or tax authority or your partner, whatever. In this way, created a system where data can be exchanged between 2 applications using blockchain underneath. When bank receive a data invoice information at step number 4, they can also make the hash, verify the data against the hash of blockchain, and say, okay, this is original invoice, was done, 2017. More invoices you have, you can build a history. Yeah, you can build a reputation, behavior, and be for a bank, as a trusted party. So we can decrease risk, we can increase trust, and we can also decrease operational cost. What does it mean? That at the end, Is the coverage will be go upper, you know, up to 100%, or fee will go down, and it's good for business for everyone. Yeah, so how that in hash looks like, so Sergey will now show it. So what we do underneath, so he is showing EtherScan. EtherScan is representing what is going on Ethereum blockchain. Yeah, so we create a smart contract like 4 minutes ago. And this is a smart contract. Now he's using another application just to see. So now we are reading directly from internet, this public data. Yeah, you can see URL to the original data, to exact online APIs, and hash of this file. By calling this API and provide, you know, all the security checks, you can get access and verify it. Yeah? Let's move on. Yeah, so you might ask, where is the data? Where is it stored? It's often a question which we ask. So it's stored in all of these points. So immediately after Sergey creates invoice, we create a hash, and that hash in a few seconds distributed across globe. When we mean across globe, we really mean it, right? So it's 1,000 nodes across globe, which synchronize each 12, 17 seconds or so, at least on Ethereum. So this is where the data is stored. Let's go to some terms about blockchain. So yeah, it was a really nice story, probably. I just heard, you know, blockchain. Not that close, but. So yeah, what is private and a public key? Yeah? So public key is derived from private. This is what you might hear. How to understand it? So it's easy. If you think about email, yeah? Your email address will be your public key. Your private key will be your password. Simple, right? Next one, what is transaction? Transaction is contained from, to whom you send, what the value you send, and fee which you would like to pay. The same basically with email. You just send email from yourself to someone else. You need to know just recipient, and instead of body, you just transfer some value. It can be money. In order to sign it, there is also cryptographical algorithm like digital signature, so it will use your private key, which is your password, to sign the message, to confirm that this is you who sent it, not someone else, this is you. All this happen what we call wallet. If you think about what is wallet, wallet is just a client, like your email client, so it can be on your mobile phone, it can be on a browser, it can be anywhere else, so it's like your Gmail client on your mobile, or it can be like your Outlook. So those things are called wallet. So wallet will do this operation for you, create transaction, sign it, and send it to the network. When it's sent to a network, so it's called like a pool. Those transactions will be there, and depending how much you pay as a fee, your transaction will be processed first to last one. Yeah, so then process of mining, yeah, I will skip it. If you would like, then later on. So process of transaction, so each few seconds or few minutes, depending on implementation of blockchain, block will be created out of those transactions. It's called mining process. That transaction, that block will be linked to previous block with the hash of that block to previous, to previous, to previous. People or organization who do it, you know, this mining, they call miners. And it's happen inside one full node. Yeah? So full node will contain all the information from the very beginning. All the transaction which is happening in that node. That's it. Hebben jullie vragen? Yes, please.
You just showed us the data is all over the globe.
Yeah.
Right. The hash is all over the globe.
Yes. Yes.
And where is that stored?
Okay. So yeah, can you see? Yeah. So invoice is stored here in our data storage. Hash is stored. Yeah, yeah. Then bank will read this hash. Together with the hash, they will read URL to our endpoint, and they will say, based on this URL, give me invoice. And user will decide yes or no. User will say yes. Then Exact will send that information, the invoice or inventory or any other digital assets. So data about invoice is saved in